In this lesson, we will look at some more uses of the Truffle framework, mainly unit testing. Unit testing is the process in which we look and verify whether every part of the application works as it is intended. For smart contract, this involves testing the correctness of the functions. By testing each component, we can increase the overall reliability of the DApp on Web3.js and can catch errors easily. Unit testing is important because it helps us identify bugs early. By doing so, we can save a lot of time and resources since problems can be fixed before the contracts are deployed. It helps in ensuring contract reliability. It gives developers the confidence that the smart contract will function as it is intended to, even under edge cases. It helps in maintaining the integrity of the D app. It helps in facilitating maintenance. The unit test acts as a safety net, allowing developers to make changes and updates to the smart contracts, knowing that the existing functionality won't be broken. It also helps in improving code quality. This allows us to write higher quality, more maintainable smart contracts. We'll be using Truffle again. Let us revise creating a new project. Use the truffle init command in your terminal. It initializes a new truffle project with the necessary folder structure and configuration files. It sets up a contracts directory to store your Solidity smart contract files, a migrations directory to handle the deployment, a test directory to write and run the unit tests, a truffle config.js file to configure your truffle project settings. So these are the components of the project. Smart contracts. The contracts directory is where you store your Solidity smart contract files. These are the core building blocks of your DApps. The migrations directory contains deployment scripts that handle the process of deploying your smart contracts to the Ethereum blockchain. The test directory is where you'll write and store your unit tests for your smart contract. The Truffle config.js file is the main configuration file for your Truffle project. It allows you to customize settings such as the network, compiler, and other project-specific options. Now let us write a basic test for a smart contract called myContract. This test checks if a function called myFunction returns the expected value. First, the contract is loaded using the artifacts.require command. Artifacts store all the data about the compiled contracts and are necessary for deployment. Next, the test suite is defined with the contract. It function defines the test case. Then the contract instance is obtained with await myContract.deployed. Then in the next line, my function is called. Then the assert function compares the returned value to the expected value. Truffle uses Mocha and Chai libraries as the testing framework and assertions respectively. Mocha provides a robust test runner that makes it easy to organize and execute your smart contract tests, where Chai offers a powerful assertion library. Before testing our smart contracts, we need to compile them. Use Truffle compile command, which converts the code into a format that can be deployed and interacted with on the Ethereum blockchain. When you run the command, it finds all the Solidity files in the contracts directory and generates the necessary artifacts such as the application binary interface and bytecode. These compiled outputs will be stored in the build contracts directory, making them accessible for your testing and deployment work. Execute the unit tests, we use the truffle test command provided by the Truffle framework. This command will scan the test directory and run all the test cases defined. Here are the steps. First, open the terminal and navigate to the roots directory of your project. Then run the truffle test command. Truffle will compile, deploy your smart contracts on the local Ethereum network and run the test cases. It will then display the results of the tests. We shall now test the deployment of the smart contracts. We run these tests to verify that our contracts are being deployed successfully and have the expected address. Let us look at an example. We will check whether the My contract has been deployed correctly by checking the contract instance has a valid non-empty address. The contract is first loaded using the artifacts require command. Then the test suite is defined in the next line. The it function defines the test case. Here, to test whether the contract is deployed in a valid address. The await command then obtains the contract instance. Then assert statement verifies the contract has a valid address. We shall now verify that the state variable in a smart contract is updated after calling a function that modifies it. It uses the my contract, which has a set state function to update a state variable and a get state function to retrieve the value. The test first deploys the contract and obtains an instance of it. It then calls the set state function to update the state to a new value. Then it calls getState function and asserts that the state matches the expected new state value. While building smart contracts, it is necessary to ensure that the contract correctly emits the expected events. Let us look at the test given below. The test here first deploys an instance of the myContract. It then calls the trigger event function, which is expected to emit an event. This test then checks the logged events whether the event was emitted correctly, asserting that the value property of the event matches the expected values. It is crucial to ensure that a contracts properly handle invalid or unexpected inputs. Truffle allows you to write tests that revert the transaction when provided with invalid data. The test case starts by deploying an instance of my contract using await command. It then calls the invalid function on the contract instance, which is expected to revert the transaction due to the invalid input. The test then uses a try catch block to capture the expected revert error. If the transaction does not revert, the test will fail using the assert.fail. Finally, the test asserts that the error message contains the word revert. Before each hook and truffles testing framework is a powerful testing tool for setting up the test conditions before each individual test case is executed. This ensures a consistent starting part, allowing you to focus on the specific functionality of the smart contract without worrying about the state of contract. In the example provided, the before each hook is used to deploy a new instance of the my contract before each test. By doing so, the instance variable will be freshly deployed. When testing smart contracts, it is important to check how the contract behaves when accessed by different Ethereum accounts. The example given shows how to test a restricted function to be only called by the contract owner. The test first deploys an instance of my contract using await keyword. It then calls the restricted function using the first account in the accounts array, which is assumed to be the contract owner. The test further tries to call the restricted function from other accounts, which should not have permission. The test expects the transition to revert and uses a try catch block to verify the revert message and ensures the function was properly rejected. The assert library from the child testing framework provides a variety of assertion methods for verifying test results in your Ethereum smart contract unit tests. These powerful assertions allow you to make detailed checks on the expected behavior and outputs of your contract functions. Assert.equal verifies that the actual value matches the expected value, providing a custom error message if it fails. The assert.isTrue checks that the provided condition is true using a custom error message on failure. Assert.isAbove ensures the value is greater than the specified threshold. Here are some common testing pitfalls. Not resetting state. Failing to reset the contract state between test cases can lead to unwanted interactions and inconsistencies, making it difficult to isolate and identify the root cause of issues. Overlooking the edge cases. It is very crucial to consider all the edge cases and unexpected inputs to ensure your smart contracts can handle a wide range of scenarios. Ignoring the gas costs. While unit tests focus on functional correctness, it's also important to monitor the gas costs of your contract functions. Excessive gas usage can make your application prohibitively expensive to use. Incomplete code coverage. Ensuring that your test suite covers all the relevant code paths is essential. Overlooking certain functions or code branches can leave your application susceptible to bugs and vulnerabilities. Here are some more resources for you to go through.